Let us discuss in this video order sets. So what is an order set? First of all, it's a set where we have defined an order relation. Okay, and what is an order relation? Let's see some examples, some intuition first. For example, let's say X, I give you the sentence, X is larger than Y. Okay, so you can say a car is larger than a pen. So you are ranking the car against the pen, saying the car is larger. Okay, but silly as it is, we can do so many comparisons, right? We could say tastier than. So we could say a fruit is tastier than a stone. I don't know. Faster than. We could say these are more colloquial, but we could say also, for example, that X is a subset of Y. Okay, so two, now X and Y would be sets themselves. And then if X is a subset of Y, that means that all the elements in X are elements of Y. Then X is contained in Y, and that is an order relation. Okay, we could say that X is a part of Y, or we could say that X is a divisor of Y, like X divides Y. Okay, these are all possibilities. So we probably agree that these are order relations because they rank elements, okay? Somehow informally, this is not a definition, it's just an informal way of saying what an order relation is. So an order relation ranks elements in a set against one another. Okay. More examples, if we now think about the set also, we could say strings of text ordered alphabetically. Okay. Or we could do a sillier example. Let me show you that depending on the order relation we consider, the same elements of the same set can be ranked in different ways. So let's say that now we consider the set of fruits. I consider lemon, orange, grape, and watermelon. Okay. And the order relation could be X is sweeter than Y, or we could say as sweet as. Okay, just to be on the safe side. So we do like this, then the order would be the lemon is less sweet than the orange. The orange, now here it depends, but in my experience, the watermelons I have seen, they are usually less sweet than the grapes, but you may have a different experience, so up to you. But let's rank them like this, okay? Now, another possibility would be to say that X is bigger than y. If I do like this, then the one that comes first is the grape, that is the smallest, then probably lemons, oranges, and definitely watermelons. Okay. You see that the order for the same set, the order is a little different in both cases. Okay, so this is an example that for the same set, depending how you define the order relation, you will get different results. Okay, so now, what is an order relation? Let's write down the mathematical definition. So, an order on a set S is a relation denoted, let's denote it with the less symbol. Even this is, we have used this in a very specific context. This is a more general context, okay? And it has, this relation must satisfy two properties. Okay. So the following properties, property number one, let's say X is an element of S, Y is an element of S, Y belongs to S. Then one and only one of the following statements holds. So there are three possibilities. Either X is less than Y, or X is equal to Y, or X is bigger than Y. Okay. So only one of these can be true at once. And then the second property is the transitivity. Okay. So whenever we have three elements, X, Y, and Z, that belong to S, if X is less than Y and Y is smaller than Z, then guess what? The transitivity property says that X is less than Z. Okay. So this is you can read this as X is less than or smaller than, or X precedes Y. Okay, these are different ways to say. Whenever we say X less or equal, let me just note, whenever we say X less or equal Y, this means that either X is smaller than Y or X is equal to Y, but we are not specifying what is the case. Okay, here we are being a little lazier. This is the opposite, whoops, of X being bigger than Y. Okay, so whenever X is not bigger than Y, that means that it's either less than Y or equal to Y. Okay, so this is a relation of order with these two properties. Now, once we have defined a relation of order, then the definition of an ordered set is trivial, right? An ordered set is a set S in which an order has been defined. Okay. So for example, well, probably you are thinking the same example as me. You could say the rational numbers. Okay. This in this case, we have, let's say that we have two rational numbers, R and S. Okay. Then the order here would be that R is smaller than S. If and only if R minus S is less than 0. Okay. Or if you want, instead of writing it this way, let's write it in on the positive. S minus R is bigger than 0. So for example, I have 1/2 and 1/3. So is it true that 1/3 is smaller than 1/2? So we take the definition. 1/2 minus 1/3, that's 1/6, right? And this is positive, so yes.